Okay, today is lesson 5.4. We are reviewing quadratic solving day 1, and we're doing the second day of quadratic solving. This will be a brief lesson because we spent a lot of time in class getting tennis ball lab graded. So I gave them this problem to try to start with, to remind them what we talked about before. Do I split it right away? No, what do I got to do first? Divide by 2. I divide both sides by 2. Does that affect my sign in the middle here or not? No, dividing by 2 is pretty innocuous. If I had divided by -2, though, remember I'd reverse the sign. So then this becomes an 8. Now I'm going to split it into 2 parts because that's what you do with absolute values. You say the exact thing you see without the absolute values, x minus 4 greater than or equal to 8. And then you write the exact same thing you just wrote, x minus 4 greater than or equal to 8. But one little exception. I changed the 8 to a what? To a -8, and then that is like multiplying by a -1, so therefore that sign has to reverse. Okay? Then I can add 4 to both sides, and I will have x is greater than or equal to 8 plus 4 is 12, and then I have here plus 4, x is less than or equal to -4. Then if I put it on a number line as I suggested that you might want to, here's -4 and here's a 12, and then I say it's less than or equal to this, and I say it's greater than or equal to that, you can easily tell the intervals, -infinity to -4, bracket on the -4 because it can be equal to, see, the -4. And then the last part is 12 to infinity. Raise your hand if you felt comfortable with that part. Okay, good. Then you've mastered the first part of the quadratics material. I'm going to pause for a second while I get to the second part. Okay, so now I got to review the second part of day 1, which was, do you remember on a problem like this, it said, this is just the problem number, the one there, it said to set it equal to 0 first, find the zeros, then put them on a number line, and then test the intervals around those spots? Let's do this one. Would you please solve this one and set it equal to 0, then find those important zeros, hopefully it factors. If it doesn't factor, you got to use the quadratic formula to find the zeros, but I think it'll factor. And then you have to test this interval and this interval and this interval and see which ones work by testing a point, like test the point 2 if it's between 1 and 3 or whatever. So find your roots, then test spots in between and figure out whether the answer comes out positive or negative. That's going to make what's called a sign chart. All we got to do is see, is this come out to positive or a negative, because it's comparing with 0. All right, I'm going to shut up now and let you work. Okay, so let's give this a try. Unfreezing my board here. All right, good. So when you move this to the other side and that to the other side, hopefully you had 2x squared. Probably the 2 a little higher. There we go. And then plus x, and then -3 is less than or equal to 0. Then this part right here factors. If you can factor it, you should. 2x, x, and then let's see, a plus 3 and a -1 possibly would work. I'm going to check it. Outside makes -2x. Inside makes positive 3x. Net, when you add them together, is positive x. It worked. Yay. So I have 2 answers. This one right here has to be equal to 0. 2x plus 3 equals 0. And this one also has to be equal to 0. X minus 1 equals 0. X equals 1. X equals -3/2. So those are your 2 important spots, -3/2 and 1. And just to clarify, those are zeros. They make it equal 0. So do I want it to equal 0? It says or equal to 0, right? So those are good spots. They work. They satisfy the equation. So I'm filling them in, and I want to put a little z above them to stand for zeros. Those are the zeros. Now I test the spot in those intervals. Like 0's in here. I could test 0. Now let me show you what I mean by testing that. If I put a 0 in this equation right here, I'm going to circle it in green. If I put a 0 in there, I don't even care if exactly what the number comes out to. I know it's going to freak a lot of people out, but that's what makes this quicker, is if you just put in a 0 here and a 0 here, and I say that comes out positive and that comes out negative, thus a positive times a negative makes the answer negative. Are negative numbers less than or equal to 0? Yes, they are. And therefore, it works. It works in there. Now, can I just assume that the ends don't work? I will say 9 times out of 10, the ends won't work if the middle works, as in it probably doesn't work here or here. But on the test, we like to test you on the exceptions to the rule, so don't assume that. Okay, so you should test in there and find out if it really works or not. So I'm going to test a 2. I stick a 2 in, and it goes fast. This is positive. This is positive. Once I put a 2 in to my equation. Positive times a positive makes a positive. And a positive is not less than or equal to 0, and therefore it does not work. So I double-checked it. It really doesn't work. And the last one is check a big negative number. And can anybody confirm that it also does not work out here? Agreed? Okay, good. Yes?
The way I solved it was it didn't set it equal to 0, but I set it to lesser than or greater than or equal to 0. Yeah. And
you set it to greater than or equal to 0.
Or lesser than or equal to 0.
I think you mean less than or equal to 0.
Yeah.
Okay?
But and then I solved it through. I got the same answer at the same interval. 2x squared is negative. We moved it to the other side. Yeah. And it's still got the same answer.
Okay. So you just moved this to the other side and made it -2. Yes, that'll absolutely work. You made your life harder by doing that because your lead coefficient was negative. I recommend that you don't do that. All right, I'm going to pause for a second. Okay, so there is an example of what we did before. Today's is really just, we already had covered pretty much everything that was tough on that first day. It was kind of a long day, you may recall. So let's get to the assignment for day 2, which is very similar to day 1. It's just an extra day to kind of let this soak in, make sure you really get it. Let's do number 17 together. The ones that are circled, I have double-checked them. They are all reasonable. The ones that have circles around them. So 17, 21, 25, 33, 35, and 36, and 3A and B. All right, I think I'm going to chop out 1 just for time because we took up so much time at the beginning of class with that grading. I'm going to chop out 1 for you, and I feel like number 35 is as good as any to chop out. Okay, so that gives you just a little break on having a lot of homework. All right. I don't understand what you mean. Let me check. That was the last day I have. You have more than that?
No, on the first page.
Okay. You are not doing 30. Just the ones that are circled was my original assertion, and then I crossed off one of those. All right, so number 17, putting parentheses around this, greater than or equal to 0, I'm hoping it'll factor, because if it does, I've got my roots, and those, just to clarify, are the x-intercepts of a parabola. So if I say x and minus 3 and, no, it's not going to work. Is it plus 3 and minus 1? Plus 3 minus 1. Okay, good. Then x equals -3, and x equals positive 1. Okay, good. So I'm going to go and put it on an actual parabola this time and show you what it would look like. Do you get my parabola? If I was going to graph a parabola here, the parabola would look something like this. Do you get that it's a right side up parabola? And those are the roots, and that's kind of... So do we have to do it in 3 dimensions? I think it's a good idea to understand this. This actually will make a lot of sense, I think, to a lot of you. Where is the parabola bigger than 0? In this zone and this zone. Do you see how it's sort of like, this is sort of like your number line that I showed you before? And that I can tell by graphing it, actually sketching the graph of it right away, and I can tell where to shade. Okay, now the important spot then is, that's really, really critical, is that works, and that works because of that or equal to sign right there. So what is the final actual answer? -infinity up to that root right there, which was the -3. Works at -3. Union with, starts working again at 1, bracket, 1 to infinity. Do you get I didn't even have to test intervals that way? Does that make sense to you? I didn't have to check, because that's a really common place for kids to mess up on the checking intervals. They check a number like they put in 3, and they mess it up when they put it in, and they don't get the right thing. Like they should notice that that should work, okay? But they somehow make a little math mistake in there. If you sketch it, that's another way to do it. All right, so this next one, let's subtract 4x from both sides. So then it'll be x squared minus 4x plus 4 less than or equal to 0. Again, what if this thing wouldn't factor? This one will. But if it wouldn't factor, quadratic formula would still get you the roots. It'd just be much more messy. Now, I'd like you to do these in 3 dimensions, as in the way I just did it a second ago. So this is just a parabola that's going to touch at, well, wherever the roots come out to. Did you say x and minus 2 and minus 2? Did I got that right? But wait a minute, it's touching at the same exact spot. It's touching at 2. What does that mean? Boing, bouncing off of the x-axis there. So now, what were we looking for? We were looking for less than 0 or equal to 0. Is it ever less than 0? No. Is it ever equal to 0? Yes. So your answer is just at that one spot right there. That's the only one that works. If you wanted to test it like I did before with intervals, I could say, I'm going to test this interval and put in like 5. When I put in 5, I get 9, which is not less than 0. And then I put in something like 0 to test it, and I put in 0, and I get positive 4, which is not less than 0. So it seems like it would never work, but that spot right there works. The final answer is just x equals 2, because that's where that spot is. X equals 2. And you don't have to write that in a fancy way. If you wanted to, you could put it 2 with parentheses around both sides, but actually it seems, most books will write it that way, but it seems more logical for what we know to say brackets around it, because then you're saying it works. But either any of those options are fine. Yes, sir. Would you shade everything outside the parabola? I don't understand. Underneath the, I did shade right here, and I shaded right here. Is that what you're talking about? Oh. Okay. These are done in 3 dimensions, though. The other ones didn't have a parabola. We're supposed to be learning that as you graph this parabola in here, you can judge by where the parabola is bigger than 0. Okay, and this is the part where the parabola is bigger than 0, and so this is the other part where it's bigger than 0. That's why this and this are the regions that worked. Sorry, I'm not answering any more about that right now. Okay. You can always ask later personally if you want to, but I'm recording here. So, number 33. The profit in dollars made by selling X bottles of 100% all-natural certified free trade organic Sasquatch tonic, holy cow, long name, is given by P of X equals blah, blah, blah. Apparently, X is limited to between 0 and 35. That seems important. All right. If you actually sketch this thing, remember that it's a negative in front, and therefore this is an upside down parabola. And we want to know where this function, where it can only be 0 to 35, is going to be. So let's say you end up with something like this. Let's see, the y-intercept is where x is 0, so the y-intercept would be negative 100, so it would be like down here. And it would probably go something like that. And here's the really important thing. You got to stay between 0 and 35 for your x. So here's 0 for your x, and here's the, I don't know where the 35 is. Let's say it's over here, we'd be fine. All of our answers are going to have to limit then. And if it was, let me think, I want to have at least $50 in profit. That means that our profit function right here needs to be above 50. Okay, so I'd have to like put in wherever 50 is like that. And our final answer might be something like it's only above 50 in that little zone right there. That's a rough outline of how to do that one. You're supposed to be willing to take challenges. You're in the honors class. So this might take you a minute to figure out. Not super, super simple like the other ones were. Notice you're not doing number 8, but you are trying 3A and 3B. All right. On these, the actual sketching of the graph, sketch doesn't mean graph. So sketch is close enough. So absolute value of the inside. This is just reviewing for you. It's nothing new here. This is not the same thing as before. This is a reminder that when you absolute value the inside, let's say the shape looked like this. If you absolute value the inside, that's the kind where you erase the stuff on the left, and then you reflect this stuff over to the other side. So it looks something like that for an example. That's just a reminder of how to do the absolute value of the inside of the function. So always start your math problems by just, doing the inside, which is this. When you're done graphing that, then take it and do this to it. Okay, so just sketch this graph, and this graph. By the way, this one, if you can factor it, you should. I think you're going to like it better if you factor that. Okay, and then this one, it's already in vertex form. I'd put this +3 at the end. I think that would make your life significantly better. Now I can see the vertex. See? Look, Mom. Vertex. 2, 3. And is it a normal U-shaped parabola? Sure it is. There's no negative out in front. Okay. So there's enough hints for today. I think that's a very reasonable assignment from there. And that's all I've got for you for today.